Hello and welcome to the course of HDL Digital Circuit Design. Today's topic is sequence detector implementation using Mealy, that too overlapping type. So here we will be considering 1011 sequence that we will be implementing using Mealy and that too overlapping way. So myself Shilpa Rudravar, Assistant Professor School of ENTC Engineering, MIT Academy of Engineering, Anandi, Pune. In previous session, we have seen what is the concept of FSM, what is difference between Mealy and Moore sequence detector. So for that video, you can check the description box. I'll be pasting the link over there. Now, here you are able to see sequence detector. So what is meant by sequence detector? Sequence detector is the circuit which will be detecting a sequence 1011 which will be present in the strings of 0, 1 you are giving at the input side. So for the sequence detector, suppose this is the circuit which is detecting 1011 sequence. Input to that sequence detector is clock, reset and the input, as well as output is this output. Now clock will be positive edge trigger, as per your requirement you can give negative also. Reset will be there, and depending upon that input, the string of 0, 1, you will be detecting this 1011 sequence. So I'll be giving suppose input string of 1 0 1 1 1 0 1 1. So it will be detecting two sequence that way. So this I have explained through this. I'll be explaining this in coming part. So how to draw this state diagram? Ultimately our intention is to write a Verilog code for this, and for that you should be knowing how to draw this state diagram, because once the state diagram is there, you'll be able to write a Verilog code properly. So this particular part is clear, that what is the block diagram of sequence detector. It is having one string of 0 1, reset, clock, and output is this. So now we are implementing this using Mealy sequence detector. So as you know, over here in Mealy FSM, my present state and input is going to decide my next state and output. So my output and next state depends upon input and the present state. But in Moore, my output and next state depends upon present state only. That output is state dependent, that we have seen in the previous videos. So how to draw this diagram? For that, we'll be moving ahead with the steps. So first step is how many bits are there in the sequence. So 1011, that sequence we are going to decide. So what you need to do, there are 4 bits, meaning of that you require 4 state. So here A, B, C, D, these 4 circles we have drawn, that we have drawn because of 4 bits are there. So first step is what? Draw that many state, that many bits you are having in the sequence. So 1 0 1 1, that is the 4 bits are there, and that's why we have drawn 4 circles. Then we need to give, second step is what? You need to give name. So A is given to this first state, B is given to the second state, C name is given to the third state, and D is the name given to the fourth state. So this is the second step. What is the third step? That you need to write what is the meaning of state A, what is the meaning of state B, what is the meaning of C and D state. So for that, in the square bracket I have written 0. So meaning of A is that the reset state is there, ideal state is there, that it is detecting 0. We need to decide, we need to detect 1011 sequence. Out of that, what is detected? Nothing has been detected, so 0 is detected. Means it is the starting of your FSM. So 0 is written. Now what you need to write below B? First bit of your sequence. So first bit of your sequence is what? 1, and that's why you are writing 1 here. Now what is the meaning of C? That first 2 bit of sequence has been detected, so you are writing 1 0. And on the last state you will be writing first 3 bit of your sequence, that is 1 0 1. So in this way, first step is how many states you need to draw. Second state, a step, that name given to the states, and third is what is the meaning of A. If you are in A state, 0 is detected. If you are in B state, 1 is detected. If you are in C state, means 1 0 is already detected, and you are searching for the third bit as well as 4 bit after that. And this is D, means 1 0 1. whatever the sequence is given, that is input, from that 101 is detected, you are searching for the last bit, that is 1 or 0 is there. So this is the thing. Now what you want over here, that you need to draw the transition. From this state you will be moving to which state, so transition has to draw. Now what is meant by this transition? As I told you in Mealy, your output and the next state depends upon input and the present state. So my present state is what? If I am starting from this, my present state will be A and my next state will be B or C or D, depending upon whatever the conditions are there. So at start, my present state is A. Now already I told you, you are writing on the transition X by Z, that is input by output you are writing. In this case you are writing IP by OP. So input by output on the transition for the case of Mealy. Now whenever you are in A state, now you need to decide depending upon input and present state what will be the next state. So here as per this diagram it has been mentioned that if I am in A state and input is 0, my output is 0 and my next state is A only, because self loop is there. Now how to find out that? For that this table has been created. Now how to create it? Once these 3 steps has been done, you need to draw this table. So you need to draw first present state. So you are in state A, you can be in state B, you might be in state C, you might be in state T, and that's why A is written, B is written, C is written and D is written. Hope this idea is clear. That many states you are having, that name you need to write here. Now second is partial sequence detected. Now what is the meaning of this? That if you are in A state, what is the meaning of that? 0 is already detected. So that part you need to write. So in A, 0 is detected. Now why I have written it twice? That reason I will be telling you afterward. Again, if you are in B state, what is the meaning of that? 1 is already detected. That's why in B you have written 1 1. Now what is the meaning of C state? That 1 0 is already detected. So here 1 0 has been written, and for D 101 is already detected, and that's why 101 is written. Now why this written twice, 2 times? So in this I need to decide my next state. I need to decide my next state and output depending upon input as well as present state. So present state we have written, that is A, and input might be 0 or 1. There are 2 options possible, 1 bit. There are 2 possible options are there, that is 0 or 1, and that's why the things have been written in such a way that when I am in A state, meaning of A state what? 0 is already detected, and if input is 0 or input is 1, what will be my next state? So input is 0 or input might be 1. So that's why we have written this twice. So my next step I need to find out. Here it is written A and B, how that is coming. So I'll be telling you that thing. But is this part clear? That is A state, 0 is detected. Your input might be 0 or 1. And that's why depending upon that you are finding next state and the output. So now what is this part? Now here I have combined these 2 columns. So 0, 0. I have written 0, 0 here. 0, 1. I have written 0, 1 here. 1, 0. 1, 1. Same way I have combined these 2 columns so as to show this particular part. Now what you need to do? Now you need to concentrate on this particular part. That I am in A state. I am in A state. So this is my A state and my input is 0. My input is 0. So check this, what you are getting? 0, 0. So is there any state naming 0 from A? So there is state naming 0. 0, 0 means 0 only. So we can go that if there is a state and input is 0, is there any state naming 0, 0 is coming? Yes, this is 0 means 0, 0. And that's why you need to draw a self loop from A to A only. On transition you need to write input is 0 and output is 0. Now why you need to write output as a 0? Because when whole sequence, that is 1 0 1 1 is getting detected, that time only you will be writing output as a 1. So when you will be getting output 1, when a sequence is getting detected, that time you will be writing 1. So first I need to detect 1, then after that 0, then consequently after 1 0 there should be 1, and after that 1 0 1 there should be a sequence or bit 1. Then 1011 is getting detected, and at that time your output will be 1. So before that it will be 0 only, and that's why at this moment nothing is detected because 0 was the input, and that's why output is 0. So hope this part is clear. So we have completed this particular part. I'll be taking one pointer so as to show you. Now this part is over. Now what is the next thing? I have completed this particular part. I am on A and I have drawn self loop. On the transition I have written 0 by 1, 0 by 0. Now next point, if I am in A state, and what is the meaning of A state? That 0 is already detected and my input is 1. So is there any state naming 0, 1? Because we are combining this 0 and 1. So 0, 1. Is there any state naming 0, 1? Meaning of 1 and 0, 1 is the same, and that's why that state is available here. And that's why from A, where you are going? On state A, where 1 is getting detected. So 1 is getting detected over here because you have written this 1 over here. So 1 is getting detected, and that's why you are drawing like this. So from A, it will be moving to state B when input is 1 and your output will be 0 only because yet sequence is not detected. Now, if you are in B state, what is the meaning of that? 1 is already detected. From this sequence you are able to see. Now you are searching of another bit. So I am in now B state. So here, so I am in B state. What is the meaning of B state? That 1 is already detected. So you are able to see, and your input might be 0 or 1. If input is 0, so if you are combining this 1 0, so this is 1 0 present. Is there any state naming 1 0? Yes, that is available over here, and that's why from B you will be moving from B to C. So C is there. On the transition, what you will be writing? 0 by 0 because input is 0, output is 0 because output is sequence is not detected yet. Now, is there any state naming 1 1 if input is 1? No, there is no state naming 1 1 because there is 1 and after that 1 0, and that's why what you need to do? Cross left side bit. This is the rule. Cross left side bit. Is there any state naming 1? Yes, that is here only. So from B you need to move to B only, and that's why you are writing or you are drawing this self loop 1 by 0. Hope this part is clear. Now why you are in same state? What is the meaning of crossing this? That after 1 detected, if you are having another bit as a 1 coming, meaning of that it might be a first bit of your sequence might be like this, or bit might be coming like this. So if 1011 is coming after this, so this can be considered as a first bit of sequence because this is the first bit, and after that if 01 is coming, 011 is coming, means I will be detecting my sequence, and that is the reason this is the simple way to understand why we are cutting this one. Okay. So reason you should be knowing. Only merely cutting this one is not a way, but you should be knowing the reason why we have gone to state B where 1 is detected, because this second one can be considered as a first bit of your sequence. Your sequence might be like this after this. So that is there. Now you are in stage C or state C. What is the meaning of state C? That 1 0 is already detected and you are going ahead with the third bit detection. Now whenever my input might be 0 and 1 in that state, so is there any state naming 1 0 0? No. So is there any state naming 0 0? Yes, that is 0. So that's why you are moving from C to this A. Why? Because 0 is getting detected because I have crossed 1, I have crossed 0. So 0 is there, you are in A state. Now why we are there? Because if we have detected that 1 0 and if your input is 0, meaning of that sequence is lost, you need to start from the beginning. After this nothing, whatever is coming, you will not be able to detect the sequence, and that's why you need to start from beginning, and that's why it is at A state, which is the recess state or first state. After that, is there any state naming 101? Yes, and that's why from C you will be moving ahead with the D, and you are writing 1 by 0. So here, once that has been done, what you need to do? You need to move ahead for the D state. Now you are in D state. Sequence is not yet detected, but yes, partial sequence is detected, 101. Now, if after this, if 1 is coming, means your sequence is getting detected, and that's why from D, where you will be moving, just check. Whenever on D, 101 is already detected, your input might be 0 or 1. If 0, check 1010 is there or not. So there is no such state available. Cross this. Is there any state naming 010? Suppose not. Check any state 10 is available. Yes, this is available here, and that's why you are moving from this to this. And what you will be writing, that is 0 by 0, because input is 0 and output is yet not detected. Now last point, 1011. Yes, it is a sequence. So if you are in this D state where 101 is detected, your input is 1. So 1011 is there, sequence is there, but that state is not available. Just cross this. Is there any state naming 011? No, that is not there. Cross again left side bit. Is there 11 available? No. Is there 1 available? Yes. So from this, it will be moving to this state, that is B. Now, as sequence is detected at input 1, so 1 by 1 you will be writing. So at this moment, your sequence is detected. Okay, so hope this part is clear. Now this we have considered for the overlapping case. Now what is meant by overlapping case? Suppose I am having sequence like 1011. So this is my sequence. It is already written over there. So this is my sequence 1011. But while giving the input, I will be giving a string of 01. So suppose that string of 01 I have given after certain delay time, I have given 1 first. After some time I have given 0, again 1, again 1, again 0, 1, 1, 0, 1, 1. So this string of input I have given over here. Now what output I will be getting? So output of sequence detector is what? It will be 1 when whole sequence is getting detected, that is 1011. But when 1 I am giving, is it a part of sequence? Yes, but whole sequence is not detected. So that's why output will be 0. Again, 0 is applied as second bit to the input side. 10, is it a sequence? No, that's why output will be 0. I have given as a third bit as a 1. Still it is not a sequence because sequence is 1011, and that's why output will be 0. Now consecutive 1011 you are getting over here, meaning of that sequence should be detected here, and that's why output is 1 at this point. So here this output is nothing but the output of this. So 0 you will be getting at the first clock cycle, 0 again you will be getting at the second clock cycle, again 0, and again 1 at the fourth clock cycle, and here your sequence is detected first time. Now what is happening in the next part? That suppose after this also the sequence of 01 is coming over there. So 0 is there, so it's not a sequence, so again it will be 0. Now if 1 is there, again sequence is not there, 1 0. Whenever we are starting 1 0 1, still it is not detected, 1. Now can we see this is the second sequence is getting detected? So here this is the second sequence, 1011 is getting detected, and third over here again I can say this is 0 and this is 1 1 is coming. So from this string of 1 I am detecting this third sequence, that is 1 over here. Now why it is called as overlapping? Because this last bit of your first sequence is acting as a first bit of your second sequence. Again I am repeating, 1 2 3 4, that is fourth bit is acting as a first bit of your sequence. So I have overlapped this. This is acting as a fourth bit also, and this is acting as a first bit of your next sequence 1011, and that's why it is called as an overlap sequence detector. Hope this idea is clear, because this last one is acting as a first one of your this sequence. Last one of this sequence is acting as a first one of this second sequence, and that's why it is an overlapping sequence detector. if you are considering this as a first bit of your next sequence, then your output will be different. This I'll be explaining in the next session. So hope this overlapping concept is clear. Now I need to prove this. So how to prove this? So let me explain this using this particular diagram. So now check. Over here you are able to see this is input 1. So suppose I am in present state. You need to verify, you need to tally whatever diagram you have drawn is proper or not. So at the starting I am in A state. So input is 1. So where it will be going? When input is 1, it is moving from A to B. So you are moving from A to B. Output is 0. So that's why this output is 0. Second bit is what? So you are in B state. So that's why I have written that I am in B state. Now when you are in B state and input is 0, so whenever you are in B state and when input is 0, it is moving to C state, isn't it? When input is 0, you are moving to the C state. So this is C is written, output is still 0. This is verified. Now whenever you are in C state and 1 is coming, you are moving ahead with the D state. So 1 by 0. And D state is there, that's why D is written, output is still 0. Now just check whenever you are in D and when input is 1. So where it is going? When input is 1, it is going to B state and here your output is 1, isn't it? And that's why 1 is coming over here and state is written as B. Now suppose you are in B state and after that again 0 is coming. So where it will be going? So when 0 is there, it will be moving to the C state again and output is 0. So that's why C is written and output is 0 is written. Now you're in C state and input is coming as a 1. So it will be moving from C to D. So same is written, output is still 0. Now again, whenever you are in D state and 1 is coming. So if you are in D state and 1 is coming, again you are moving to the B state and output you are making it as a 1. And that's why here you are getting it 1. So same way you need to verify that whatever state diagram you have drawn is getting it right or not. So according to this verified that yes, whatever the state diagram we have drawn for 1011 Mealy sequence detector, that to overlapping type, is right. So hope this part is clear to you, that what is Mealy sequence detector, how to detect a sequence, what are the steps for detecting the sequence. So this particular thing we have covered. In the next part we'll be covering what is Mealy sequence detector using overlap concept, and in the coming sessions we'll be going ahead with the how to write a Verilog code, test bench, and how to simulate and implement that hardware Mealy sequence detector. So hope that part is clear. Thank you everyone.